All right, page 2 of our test review. This one's going to be a little more open-ended because all 6 problems on this page have the same set of instructions. All it is asking you to do is solve the equation using any method, and if necessary, round to the nearest hundredth. So now round to the nearest 2 decimal places. So with all of these, all 6 of them, it is possible to solve them using multiple methods. Now, I'm going to show you the method that I chose to solve the equation. The one exception here would be number 11. I'm going to show you 2 different ways of doing that because I do want to show those that remember and after being reminded are successful with doing Xbox factoring. You can factor number 11 using Xbox factoring. For the rest of you, you could always just use quadratic formula. But again, for most of these, I'm just going to show you the method that I chose to do. With any of these, all 6 of them, you can use quadratic formula. With all 6 of them, you have at least 2 methods that could be used to solve this. So starting with number 7. 7 is set up pretty nicely for square root method. If you notice here, I've got x squared as my only variable term. When that's the case, you are able to use square root method on this because we're going to be able to take and isolate that x squared and then just take the square root of both sides. So in this case, I'm going to start by getting that x squared by itself by adding 242 on both sides. So 2x squared equals 242. I divide by 2 on both sides. X squared equals 121. So now I've got my squared term by itself. I go ahead and square root both sides. And just remember when you do that in an equation, it creates that plus or minus option for us. So positive or negative could work. And in this case, the square root of 121 is just 11. So my 2 solutions are positive 11 and negative 11. So that's with square root method. Obviously, you could also use quadratic formula. In this case, since there's no x term, your b value in quadratic formula would just be 0. Moving on to number 8. Actually, these first 3 problems, 7, 8, and 9, I used square root method because, again, I have just one term that has my variable in it, and it's a squared term. So number 8 is kind of the funkier version of this, where my squared term is a parenthesis with x in it, but I can still start by just getting that squared term by itself. So I'm going to start by adding 3 on both sides, so that I have x plus 3, not 2, x plus 3 squared equals 16. And now I can go ahead and take the square root of both sides once again. That leaves me with just x plus 3 on the left side, and then plus or minus 4 on the right. So from here, I have to split this off and evaluate it because it is really 2 different equations written together. I'm going to evaluate this once, where it's x plus 3 equals positive 4, and once, where x plus 3 equals negative 4. So I'm still going to subtract 3 on both sides. So for one solution, I get positive 1. I subtract 3 from both sides, and for my other solution, I get negative 7. And those are my 2 solutions. Positive 1, negative 7. Your other method here, if you're going to do factoring or if you're going to do quadratic formula, the unfortunate thing with this problem is that you're going to have to FOIL x plus 3 parentheses squared to get it in standard form, move everything over to one side before you can even start to worry about factoring or start to think about quadratic formula. So square root method here is definitely the path of least resistance. Okay, number 9, this one's a little unique because it really depends on how you see things. Again, I see x squared as the only variable term that we have, so my mind goes right away to square root method. I'm just going to get the x squared by itself and square root both sides. For some people, you might recognize that as the difference of 2 squares, so you could factor those 2 out. Right, we've got x squared and 7 squared as my 2 terms, so that should factor out into x plus 7 times x minus 7, and then solve. You could do quadratic formula here, where your a is 1, your b is 0, your c would be negative 49. Or, like I said, I'm going to go ahead and do quadratic formula, square root method. I'm going to start by getting my x squared by itself, by adding 49 on both sides. That gives me x squared equals 49. So when I take the square root of both sides, I get x equals plus or minus 7. Super quick, super easy, which is why it's my path of least resistance. Now, those three I can use square root method on. The remaining three, I do not have that option because with all three of the ones that we have left, we have both an x squared term and an x to the first term. So I can't use square root method because I can't isolate that squared term without having just numbers on the other side of it. So with number 10, unless you're going to go with completing the square, which again, we've talked about the fact that I don't think there's anyone who uses that as their preferred method of solving, especially in this case, because as soon as you go to add half of b squared on both sides, you're going to have negative 7 halves on both sides that you're adding squared. So not going to be our method of choice. So regardless of which one you continue with, whether it's factoring or square root or quadratic formula, I'm still going to need my equation set equal to 0, no matter if it's factoring or quadratic formula. So it's worth a second before you just go default right into quadratic formula to see if you can factor this out easily. If it's taking you some time to try and figure it out, I would just go with the guaranteed method. I would just go with quadratic formula, plug in your ABC, and get your answer. It's going to save you the most amount of time. If you're sitting here struggling to try and figure out how to factor it, if it's not just obvious to you, then just go ahead and quadratic formula. Plug all your numbers in. You should still get to the same answer as long as you are doing the math correctly from the formula. In this one, this is simple enough to factor. We're trying to figure out what two numbers multiply together to be positive 12, but add up to a negative 7. So I know since it's a positive product but a negative sum that they're both going to have to be negatives. And in this case, 4 and 3 multiply to get 12 but add up to 7. So x minus 4 and x minus 3. So ZPP then tells me that either x minus 4 equals 0 or x minus 3 equals 0. So my two solutions are positive 4 and positive 3. Which again, if you did quadratic formula, you would get that same solution. Just, the steps in between would look different. Okay, moving on to number 11. So this is the one where I told you I would show you a method that I didn't necessarily do. When I did this, I still did quadratic formula just because I see that it might be factorable, but if I'm not sure that it's factorable, I don't want to do the first couple of steps of Xbox factoring, not knowing that it's factorable for sure, because you are going to have at least one of them on your test tomorrow that you're going to have to use either quadratic formula or completing the square, depending on which one you prefer. So for this one, if we wanted to try and do Xbox factoring, just a little recap for those that want to try this. Remember, Xbox factoring, the top of your x is the product of your first and your last term. So 5x squared times negative 4 is a negative 20x squared. The bottom of your x is just that middle term, so just positive 1x. So you're trying to figure out what two numbers multiply together to be negative 20x squared that add up to a positive x. And in this case, 5x and negative 4x multiply together to be negative 20x squared, but add up to a positive 1x. So from here, I go ahead and make my box. My top left corner is always my first term, so 5x squared. My bottom right box is always my c value, my number that's all by itself, negative 4. And then the other two squares come from what I just figured out. So 5x and negative 4x. And now I just work my way around my triangle trying to find some GCFs. So for this far left column, I can see for sure 5x is a GCF between those two. And I can even see right away -4 is a GCF between that right column. So if I need to get 5x squared by multiplying something by 5x, that's going to have to be an x right here, which does check out. X times -4 is -4x. And this is going to have to be a 1, because that checks, again, 5 times 1 would be 5x. Sorry, 5x times 1 would be 5x. -4 times 1 is -4. So that tells me that this factors out into x plus 1 times 5x minus 4. And that still is equal to 0. So we'll set each one of those equal to 0. X plus 1 equals 0. So x equals -1 as one of my solutions. 5x minus 4 equals 0. So I add 4 on both sides. 5x equals 4. Divide by 5 on both sides. And I get x equals 4/5. Those of you who use the formula, you probably got 0.8, which again, both of those are fine. Both are completely valid and correct solutions. So if you didn't trust yourself for Xbox factoring, if you were not a fan of Xbox factoring in the first place, you would just go ahead and default to quadratic formula. Here your A would be 5, your B would be 1, and then your C would be -4. Okay, moving along. Last one. Number 12, we've got something that looks super messy, super mean. 7x squared plus 42x equals 56. Now, something I recognize right away, and hopefully you do too, is that all three of my terms are multiples of 7. So what I can do in this equation to make it a little easier for myself is divide everything by 7, which you are allowed to do as long as you're dividing everything by the same number. So here that leaves me with x squared plus 6x equals 8. So from here, you've got 3 different options on how you can solve this. You could try to factor it, you could complete the square, you could use quadratic formula. Again, I'm not a huge fan of completing the square, and I don't think anyone out there is, so I'm not going to bother showing that one in this case. I'm going to go ahead and try to factor, because that's my preferred method. X squared plus 6x minus 8 equals 0. So I'm trying to figure out what two numbers multiply together to be -8, but add up to a positive 6. And after thinking for a little bit, you should be on the brink of giving up and thinking that you're absolutely wrong. But that's not the case. There are no two numbers that multiply together to be -8, but add up to a positive 6. There are options for if it was a positive 8 and a -6, right? That would be -4 and -2. But there is nothing for a -8 and a positive 6, because the only things that multiply to be -8 would be -4 and -4 and positive 2, or vice versa. -8 and positive 1, which that adds up to a positive 7, or vice versa, -7. So that means for this one, we either have to use completing the square, or we have to use quadratic formula. So I'm going to scooch this over, and I'm going to show this last one with quadratic formula for those that struggle with it, because I haven't shown any of those yet. And I'm just going to switch to green just so it's easier to distinguish between what I've already done and what I'm about to do. So for this, it is up to you, since you're using quadratic formula, which set of numbers you want to use. Since I divided through by 7 and made my numbers a little easier to work with, I'm going to use 1, 6, and -8 for my A, B, and C values. You can use 7, 42, and -56 if you want to. It's all going to reduce to the same two solutions. So it's up to you. If you don't want to try and remember to divide by your GCF, you could just plug those numbers in right away. It's just going to be bigger numbers that you're working with. So when I do this, I have, again, x equals -b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So here B is 6, your A is 1, and your C is -8. So now I'm just going to go through and simplify. -6 plus or minus the square root of 6 squared is 36. Looking at my numbers, I've got a -4 times 1 times -8, which is a positive 32, all over positive 2. So that is -6 plus or minus the square root of 68 all over 2. So now you have to go to your calculator, figure out what the square root of 68 is. So if I switch over to, let's see, do I have it pulled up? No, I don't. Let's go ahead and grab the calculator. So we're doing the square root of 68, which is 8.25. So this is a part where the sooner you round, the more your answer varies from what it might actually be. So what I would suggest, since we're rounding the nearest 2 decimal places, I would keep your answer to 3 decimal places until the very end. And just that helps to make it a little bit more accurate. Now, if you're showing your work and you're showing me that you're going to use 8.25 for the square root of 68 here, and you show that process and you're just 1 decimal point above or below where it's supposed to be from what my answer key is, don't freak out. You're not going to get it marked wrong because you showed that work. Now, if all of a sudden you just go straight from the stuff that's written in blue to the exact answer, except that it's 1 decimal place above or below mine, that's a different story. You're going to lose a half point for having it rounded incorrectly. So if we use -6 plus or minus 8.246, since we're rounding to 2 decimal places, we're going to keep it to 3 until the end, all over 2. And I apologize because now I'm going to be working kind of backwards. Again, we have to evaluate this twice, once where it's the plus sign, once where it's the minus sign. So we've got -6 plus 8.246 all over 2. And then, I don't like where that arrow went. And then once where it was -6 minus 8.246 all over 2. So if you grab the calculator, -6 plus 8.246 divided by 2, I have 1.123, right? So I can go ahead and show that again. So I've got, let's see, negative, where's my sign flip on here? I don't think oh yeah, there it is. -6 minus, or sorry, I did plus here. Plus 8.246 equals, divided by 2, I get 1.123. So that means this first one, the plus sign, 1.12. I'm going to do the same thing but with subtraction now. So if I go ahead and clear that out, -6 minus 8.246 and divide that by 2, I get 7.12 for my second solution. -7.12. So those are my 2 solutions for this last one. Definitely the trickiest, the most time consuming, but from what I understand, there are a few of you out there who have decided to just do quadratic formula for all of the problems. And obviously, if you can figure out the other methods, looking at how many steps we have to do, it is a lot quicker for you to be able to do those other methods. But once again, I tell you, it's your choice. As long as you're doing stuff that is mathematically accurate and a correct process, you are allowed to do it. So that is your choice. Just be prepared to work quickly to get through the test in the same amount of time. That does it for this page, page 2, which is all of our solving equations pages. all of our solving quadratic stuff. This is a mix of different places in the textbook in our chapter for where you would go for additional help. 7, 8, and 9, that's all solved using square roots, which is 9.3. 10, 11, and 12, it really depends on which method you're going to do. 9.5 was all about quadratic formula. 9.2 is technically solved by graphing, but that's where we reviewed solved by solved by factoring. And then if you're a person who is weird like no one else and really love completing the square, you can go to 9.4 for that to get some completing the square help. Obviously, you can go ahead and rewind this, watch each problem as many times as you want. Let me know if you have any questions before the test starts tomorrow during 7th hour. Otherwise, I'll see you then.